we have been tasked, I guess we can say, to do some investigations. By the way, if you didn't grab a resource, I'll grab it. Parabola has asked us for help. I know, lame alliteration. It's okay. You can roll your eyes if you want. So she's decided she's going to start the Parabola Professional Parabola Productions Company.
That's a long one.
And here's her memo. Anyone want to read the memo, or are you just going to keep listening? All right, Ava, read the memo like Parabola.
All right. Wait, like Parabola.
Whatever you want to write.
I'm starting a new company specializing in parabolas. It's a high voice. To win over new customers, to be able to show them that we know more about parabolas than any of the other function factories around. Especially since every company already sells f of x equals x squared. My customers, why? My customers will need all sorts of parabolas, and we will need the knowledge to make the customers happy. I would love to offer parabolas that are completely new to them. Please investigate all different kinds of parabolas. Determine all the ways that you can change the equation f of x equals x squared to change the shape, direction, and location of this graph. Remember that I am counting on you. I need you to uncover parabola secrets that our competitors do not know.
How much do I get paid?
Yeah, how much that?
It'll be a quadratic relationship. So, our task. Work with your teammates to determine all the ways that we can change the graph of a parabola by changing its equation and be able to describe what you did and why it worked. So, grab either a graphing calculator, which we have enough for each of us to have one, or if you want to use Desmos, in a minute, you can grab a Chromebook, and we are going to use this resource page. Now, I would advise that you work together, but if you don't have to. You are looking for vertical shifts, horizontal shifts, stretches, flips. I'm trying to think of what else. I think that's about it. Vertical, horizontal, stretch, flip, all that good jazz. So, dive in. Hopefully it's not my thing. I still
No, definitely.
Well, we were just outside, so.
Oh, yeah, probably.
This is chickpeas and red onions and
See, that
celery.
doesn't sound like that smell bad. I think that smells good.
It
It sounds like that smell good. Okay.
What am I allergic to? Vegan.
What?
I'm not a vegan, but I eat like it. 'Cause
I
my wife-
started ordering. Somebody tweeted me like, what are you to be like vegan? Just one word.
Oh my god, that's so mean.
Awesome.
Okay, let's
Just
work.
sounds like the funniest.
Work. Okay. So, make a complete graph around x squared. You should only any other you should use this complete measure over it.
Wow.
Okay, so first we have to make the graph.
Yes, because you are to document every different situation that does something different. So, on that paper, you should document how to make a vertical shift. Then in a separate section, how to make a horizontal shift. Then in a separate section, how to stretch your parabola or condense. And really, that can be in the same section probably. And then in another section,
Are we using this paper?
yeah, your resource page. You're just gonna like fill in rules. Yeah, so you don't have to take your own notes really.
Yeah.
You're just filling in
Are
rules.
these labels? The waste of paper and the human resources. Mine.
I can use paper for tomorrow's notes.
But they don't have to read them.
You do not need to be watching what I'm doing. I'm just gonna write some stuff up here that we're then
Oh,
gonna
it's like a
use.
y equals y squared.
Well, it's not.
You happy now, Jenny?
Actually, no, it's a little bit messy, but you know, it's all good.
It's so critical.
Don't
OCD. OCD.
Oh. Learn to suffer for a little bit.
No.
That's what I have to do.
He is influence on me. Good job on your bill solo today, by the way. Was my solo okay?
Yes.
Wait, you're doing a solo. Miss Wright came up to me, she's like, don't push the tempo. And
Or she said that.
I was like, I don't realize that I was.
I'm gonna show up to your orchestra concert, and I'm gonna be like, that's my best friend. When you hear, no, I'm gonna scream, that's my dad.
So,
No, when you get
first do
solos,
the
I'm
regular
gonna be like,
rounds,
that's my
then
dad.
start filling out these.
Be sure to label.
Or should we just do one of them as just a regular?
Wait, so you
round?
really don't need to take notes?
It's up to you. The resource page is more set up to give you less to write.
How do we start vertically? So vertically, how do we make it go like this?
Hold on.
How can we
Oh, my
change
life's
the
so hard.
patient name after
It's the worst being me. Oh, sorry.
Do you like add something to it?
Oh, I gotta change that to stat pods right now.
Your
Sorry
what?
about that. We have to change out to the stat pods.
What's that?
Stat
The
pods.
list that we made yesterday.
We were doing.
I was eating pizza and playing music.
Okay, well, I'm trying to help you.
You were on tour with your
Orchestra and my friend. They were pretty interesting. Leave it up there.
Make sure you use it off.
Off what? How do you
Your
plot?
plot turn. Usually you maybe turn it off. Second, that it's on as a plot right now.
What are you doing?
I'll let you plot points.
Yeah, okay.
So now it's a regular whole graph, and you change the table. So like,
What? What are you doing?
I'm making it back to a graph so that we can
Well, we
graph
have you
points.
10.
Just because that's a good even value.
Okay, so now do I draw?
Now you're good.
I was like playing around to like see how to make it stretch vertically.
Yeah. Also, for some reason, my x-axis has no actual like little markings on it.
To
Good afternoon, Nathan Hayhurst. Please come to the office. Nathan Hayhurst, please come to the office. Thank you.
Scale.
Ow.
There we go.
As you know, her
We should really be writing statements in general form, so using variables. We should really be using variables to explain what's going on.
Okay. So Jenny, I have one thing. So to make it move vertically up here.
I want to review one thing really quickly.
Wait, how did you make it actually?
I want to review one thing really quickly. We are able to modify both the input or the output. Remember that. Some people get lost that you can modify whichever one you want. If you modify the input, it happens before the action on the input. So the input is being squared. But if you modify the input, add or subtract or whatever, before it gets squared, we could write that in parentheses like here. This modifies output, right? It says do what you got to do and then do something else. So what you want to play with is what would each of these pieces do, these modifiers. And I'm not sure if I have every modification possible up here, because as we look at positive and negative values, that will tell us more.
Wait, oh, you go like that. So,
So, no, we need to make it
for
really
the I
stretch
know
it
this
so
because
it's
you're just like moving the same thing
Like
up.
one
You're
of
just
your
like
How you can
But we
explain.
have to.
So if I'm going to say I can make a horizontal shift by whatever, I know this because it, what does it do?
I'm gonna use purple.
Logically makes sense.
My life doesn't logically.
Maybe if you were to multiply it times something instead.
Times 2.
Take them.
Times 2.
What do you mean?
See what happens.
Variables can be anything we want it to be.
Huh? Nothing happens. Oh. It thins if you
That's for
multiply it. It gets
quadratic,
thinner.
like
What if I multiply it by
the
something?
regular,
Negative.
but that's after the math has been done. So this,
This is the weird part. So the more you multiply it, it gets thinner. So we just figured out how to do it horizontally, but not vertically. So let's just fill it in under, because then we know how to do it horizontally now by accident.
To make the graph of y equals x squared.
Times like.
No.
What are you doing on the second one?
Well, because the first one's supposed to be vertical. I mean, anyway. So, what should the other variable be?
Plus or add? Are we adding or subtracting?
We're multiplying.
2?
Just no, because we're using variables.
wouldn't that happen?
Y. No. What are you doing?
Ax squared plus bx
You can.
plus c.
You can strike
Not
it
necessarily.
horizontally.
Because if
No.
Yeah, when you multiply it,
Stretch it inwards.
but that's still horizontal. This has an
if you try to use that, you just want
See what happens if you multiply by negative value.
can we say something definitive about what A does or what B does? So if you want to set it up like this, what does B do? What does A do? Does it do one specific thing? Or, and actually this, so we'd have potentially something there depending on if there were coefficients up above it.
Yes.
But what, like, can we make a general rule? And I'll plug that in the Desmo so we can play with that too.
Yeah, you're still stretching it
Make a
horizontally.
different Desmo
moving it
scale.
inward.
Do you want us to like give every specific, like if it's below this, then it does this, but if it's above this, it does this?
Yeah, it does two different things.
How do I know this?
On the parabola, you can
I know this
down
because
one spot. Wait, what did you do? X squared plus x squared. Well, that, yeah, that's. No, we added it.
any real positive and positive integer.
If you guys want to come play with the Desmos screens up here, it is at your disposal.
Bless you.
So if you want to go up, just tap on the sliders, move them around, see what happens.
Yeah, look, even
So we're going to come together in like 5 minutes.
these little pink ones,
Oh, I know why that happened.
it's still.
So the A is how steep it is. Well, yeah, because it's negative now.
We have to like. Oh, and we have to like.
Oh, wait, is that as a reset?
Do you want me to go get a coffee?
I don't know.
Because there's dramatic change within that one.
Right click somewhere else. And it's easier to like.
Everything is zero, then it's flat line.
Right, because there is no, then you just said y is 0. So now you're no longer quadratic.
Oh yeah, since that's a zero.
So, Colin, I gotta stop you because you're now not in our lesson right now. No, you can stay up there, but you can't get rid of A because then we're not quadratic. That deletes this. If A is 0, you have to have an A in order to be quadratic. So hold up. If we reset, let me help you for a second. If we make A 1 and we make B 0 to reset, and look at what does B do.
It's 0.1 right now.
Point
Oh,
one.
it's
I
close
know.
enough. Jesus.
No, it's
Now
not.
it is. Now it's 0.
There we go. Sorry, I keep Connor.
You're good.
You guys.
You're just long
have
over
to
there.
chill.
This is your standard, so this is
You
just
have
y equals y equals x squared.
Okay, yep.
One simple thing.
Keeping it as large as possible.
This is what me and Jenny just
It makes
realized.
sense.
Okay.
I was raised like this. Get her.
Unless you make a, because, well, if it's negative, it goes the other way.
Have you articulated the rules on the paper?
So the absolute value of A instead.
But basically, the closer it gets to 0, the fatter it gets.
What happens when it's
Alright, Colin, I need you to articulate those rules in your notes.
Yeah, because it isn't a quadratic.
Wait, can you pull up
So, yeah. If we set it up using those old variables that we were used to, watch what changing B does.
Y equals x squared tangent. It made it wider. Made it wider.
You got your mind blown.
Why does that work?
What?
Yeah, we did.
What? You make it move like
Yeah, we
parabola
did.
shape.
I made it.
But
It's a problem.
what if we come back here?
Question.
Yeah.
Every point on that parabola that's moving on the other parabola moving on the same identical parabola-like shape, or is it a dilation of said movement?
This?
Yeah.
It's shifting the whole thing all together. Right? I can zoom out.
But basically each point is moving the same amount.
Yeah.
What'd you get? It's a point of zero. That looks like something coming out of a black hole, honestly.
Oh no, that's because C is 0.
Very good.
It's the linear stuff.
Shall use the power of technology.
You guys think you have your conjectures yet?
Not quite yet. I'm not done. But
We have like 2 ways to
We have
make it.
one.
I have 3.
We have 2 ways to make it thinner.
X squared times absolute value then.
Okay, you just log in and out.
Keep experimenting.
Wait, can you go back to the other Desmond?
This one or the ax squared plus bx?
This one.
Get you, Jack.
What do you want to do?
Are those all the things you can mess with? Like,
Well, you could multiply. Right, we could add or subtract to the
oh, I got it!
like to the answer, or we could modify the input before. We,
That's it, right?
I mean, that's all that I can think of.
Okay, you don't need to be on Secret of Jenny. We're class of 9.
This is also what I love about Desmos. If you just want to watch it
Your
You hit
feedback
play.
matters.
on the sliders. So look at as A changes. Positive, negative, more negative, going back to the positive, more positive, going back to the negative, more negative.
Wait, but what about, how do you make it move on a parabolic arc?
Now, that's a good question. I'm not going to directly answer that. But do we want to describe multiple shifts at the same time? Like, are you going to say as B turns into 3, we shift right and down? Or like, it seems awkward to me.
It moves on the inverse parabolic arc.
Yes.
Of the original. Let's go.
How would that make sense? Like, to describe to somebody. Like, we want easy rules, right? Like, when B is 7, do that. And so really, I would just cat out of the bag. We don't want to use this for our quadratic. We want to start with the parent function and look at every modification we can do to that. If you look at this modification first, it's just multiplying your output, right? Because x squared will be your output, and then a, right? You multiply, that happens after.
Okay, I'm putting this one down.
This adds or subtracts to your output. So when we add or subtract to the output, what happens to our function? Y-intercept, right? Vertical shift.
That's what I forgot.
Then,
Do you want us to make a different rule when it's positive or negative?
no, not if it's just general, like vertical shift following K or whatever, like doing exactly what K tells. Alright, I need your eyes on the board.
Oh, okay.
What is your prediction for when I make this? Let's say I make this plus H instead of minus. Not that it really matters. But what do you think is going to happen when I make H 3?
Oh, it's gonna move that way.
Because if I make K 3, it moves up, right?
But if you make H3, it'll move. It'll move to the left.
That is why we normally use minus H. Who can explain if we set it up as minus H, how we describe this? 6.
I don't know why, I just know it does.
So if you add, then it goes to the positive side, and if you subtract, it goes to the negative. So that it's not confusing.
What do you mean so that it's not? Oh, yeah, why we use the minus, yeah, just so that it's
But
not
why
confusing.
does it actually do that?
Let's discuss. If we make some tables, let's make a table.
That's the last one I'm working on, but I can't.
Let's say we have our input and our input squared,
Oops.
and then input minus something squared. So if I input like 3, I know I square it, and this becomes 9, and that's really my y. Right, but if I decide, let's just choose an h that we're working with. 2. Okay. That looks weird, but his 2. H is 2. So if I subtract 2 from my x, my input, what's it become? 1 squared. So that point has shifted from a y value of 9 now to a y value of 1. If I move towards the middle and I make x 2, this would then be 4, but what has happened to this? 0, right? Because 2 minus 2, if h is, we're going to say h is always 2 here. We're just going to take 2 away. 2 minus 2, 0, squared 0. Right? 1 minus 2, negative 1. Now that squared would just be 1, but negative 1 squared is also 1. If I make x 0, 0 squared, well 0.
Hey, can I just write this as my evidence for why it works? Can I just copy that down?
So it took me a long time. Just again, full disclosure, when I was in high school, I understand why the heck this happens.
I still don't understand fully. That's okay, I'm working through it.
When we are modifying our input values, let's just make h2 up there and make this make sense.
Why don't you just put 2 sugars?
Oh, how unfortunate.
I mean, you're right. Let's get rid of yellow. Let's stop viewing that for now. So if we look at when x was 3, our original point on the parabola was at 9. The new point is at 1, right? From our table, we can see that. If I look at x equal to 2, our original point on the red parabola was 4. Now it's actually 0. Then, as my x values continue to get closer to the middle, my x minus h actually turns negative, which when we square it, turns back positive. So when x is now 1, where my original parabola, come on, man, it's close to 1, where my original parabola is still coming down, right, as we come back towards the middle. This doesn't like me today. My original parabola is still coming down as I come towards the middle. My new one is coming back up. The horizontal shift is the weirdest to understand.
What makes it move in a parabolic arc?
So that was when we were looking at
When you add and
this parent function, and the reason this b makes it move in a parabolic arc is that b is not just a single modifier. That b is a derivative of this. Right? So this b is actually the opposite of 2 times the h value, and the h is already also affecting the parabola through a vertical change. So the only way to get your b value is for this to be something which also has had an impact on this at the same time. Vertical and horizontal. That's why they both happen. Which is why you don't want to try to describe shifts here. You don't want to use the standard form of our parabola to talk about shifts. Yeah, C will be a vertical shift, but you can't just change C. That comes from the original H. Right? So that's why we look at... I have too many tabs open, I'm sorry, guys. Why we look at each individual shift alone. So if I just compare parent function to AX, that just changes intensity. It just changes steepness. Right? If I only look at the plus K, it's vertical shift. Then, if we only look at the H, watch it play out. Positive, negative, but that's when we have X minus H. Because the H value is going to do the opposite of what you think it is. So that's why at negative 3.8 whatever, the reason we use minus H is if H is negative, then it's going to shift us left. If you talk about plus H, it does the opposite of what you think it does. Vertical does what you think it will do. Whatever K is, it does that. But here, we use the opposite of H. Or, and again, it's your options, if you use the positive H, if you set this up as X plus H, then it does the opposite, right? We have a negative H, it went right. You would normally think a negative would go left. That's why we compensate for that right here. I'm not expecting us to totally get all this right now. We're just making some rules. So let's articulate on our notes page, make sure that we all have the same stuff. This is really blurry. I don't like that at all. So, easiest thing to do. To make the graph of y equals x squared, what do you want to say first?
Vertical shift.
Vertical shift. You can
Add a number together.
yeah, add or subtract.
Yeah. But you can just say add a number and the number can be negative. Right?
Yeah, you can just add a number. Right? Add a constant.
This new equation would look like x squared plus k. Could you do plus or minus?
You can, but then we wouldn't be able to talk about k's value as a positive or a negative. If we just say plus k, then you know when k is negative, it shifts down. If we want to make the graph of y equals x squared, let's say stretch, we what?
Stretch horizontally? Multiply x.
Just the stretch, the changing of the steepness.
Multiply x squared by number. Oh yeah, yeah.
So when we write ax squared, we know that that has to square the value first because of order of operations. What does it do if a is negative?
It makes it wider.
Yeah.
Oh, wait, not, oh, never mind.
Goes negative. Goes towards whatever.
Yeah, flip it has
To make y equals x squared flip, you just make a negative. So if you put that rule following our rule about stretching, that's going to tell us we know it is also stretching. But if I just make it negative 1, hey Colin, you with me? If I check your rule sheet, you got these down. If I make a -1, all it does is flip the parabola over because it's giving you the opposite outputs that you would have had originally. So I'm saying find your output and then make it the opposite. What else? To make y equals x squared. Yeah, but we don't really want to do that because that isn't in regards to the a equals x squared parent function. We can modify the input through addition or subtraction. Now, here's the trick, and this comes down to your options. If you write it like x plus h squared, it does the opposite of what h would make you think. So, h is -3, actually goes right.
Wait, so that means that
Or just hang on to it for a second. Or if you write it like this, that will do what h makes you think of. So if h is -3, well, now it's the opposite of -3, so it will actually add here. So it takes some playing. You gotta like just practice these to get used to it.
So that means that for our draft from yesterday, we're gonna have to have a really small multiplier.
We're still trying to figure that out.
I think we're gonna have to have a really
So the rest of the time, you guys can work on your homework or ask me questions if you'd like. We're going to keep using those as we figure stuff out. Unless you have more that you want to doubt, we could play with it. If we look at parent function, ax squared plus bx plus c, we can talk about what modifies, but we can't really just modify a or b or c independently because it comes from the perfect square binomial where you square that. So that's where that all drives back to.
Yeah, we found a really
weird one. So when you subtract x squared by 1 divided by 1 divided by x, I don't know.
Fine. It's a Disney thing.
So that comes down to domain possibilities, right? Because you can't divide by 0, which creates your asymptote there. You guys learn what an asymptote is.
Was it hard?
So, I'm going to put it on business. You can ignore me if you want.
What? Oh, have you turned in your skills and your audition?
No, it's like
What solo are you playing?
And you're you playing solo?
I was gonna audition, but then I forgot to practice. So
Minus.
I'm gonna show up to your concert.
Well,
Like,
this
that's
is-
my best friend.
Yeah, it was just a solo piano something.
Okay.
So, check this out. The gentleman in the back goofing around with their calculators found something interesting. You can ignore me if you want, but we're just going to talk about asymptotes really quick.
What?
They set up x squared take away 1 divided by the x value. Now, when we are modifying the denominator, as my denominator gets bigger, this has a less and less impact. Right? As my denominator gets bigger, the fraction has less impact. So as my denominator gets smaller or closer to 0, it has more of an impact. Then if you look at the x squared, whether it's negative or positive doesn't matter since it's getting squared there, but it does matter whether it's negative or positive here. Now we can't divide by 0, which creates this asymptote at x equals 0. X equals 0 never can exist in this function. Hence why this comes negative. Then as it passes the point where this factor actually will increase the values, or this factor is actually always increasing, but now it's increasing substantially. Then it goes here. Just think about 1 divided by a half is like times 2. 1 divided by a third is like times 3. Then, as these become positive, my x values, it actually subtracts and pulls it down. But even though x is negative, this is positive. So it was positive, but then got pulled down. Right? Does that make sense at all? You don't have to understand this, but the guys in the back were playing with it. So, Gunnar? Asymptote. So this goes infinitely far down as this gets infinitely tiny. So if x is like 0.000000001, this number becomes really, really big. Right? Division by a tiny number makes a big number. So then that subtracts it really far. That makes sense? And this starts really small. This 0.0000001 squared is twice that many zeros between them.
That is wait, does that make one long infinite line?
No. Well, there's an asymptote at 0. So this line, the purple line, wants to get infinitely closer to the y-axis. But as you zoom in, you can see it's not. Right? So I could go way far down. So I'm at like negative 500. This is not touching the y-axis. You have to get infinitesimally small to be able to see the distance between them.
Keep going down. It'll get infinitely closer.
Well, yeah, but not for a long time.
Hey, will it ever get to one infinity?
I do not know it.